Hello guys, this is Mishako H, and in the past we have already discussed integers and floating points. So right now we're going to discuss characters. And the first thing that you should know in characters, if you're migrating from C or C++, is that in C and C++, characters is usually 8-bit wide because it uses ASCII, okay? But now in Java it's 16-bit because Java was envisioned to work internationally. It adopted using Unicode, and Unicode has very many characters, so the range of a Java character or characters is from 0 to 65,536 because it uses Unicodes. So the standard set of characters known as ASCII still ranges from 0 to 127, although currently there is extended ASCII codes which makes it up to 255, but in the past it used to be 1 to 127. For global portability and to cover other languages like Chinese, Katana, Hebrew and Greek characters, Java adopted using Unicode. And you can see Unicode, the first 127 characters is just same as ASCII characters. So if you look at, for example, here number 65, decimal number 65 represent A, and this is ASCII, and then here number 65 represent A, okay, capital A. Small a, as you can see, 97 is different from capital A. So if we go here and look for number 97, you'll find it's the small a, okay? This difference, or you have to present a character differently, capital and small letters, okay? So this ABCD is the Latin characters. So there are two ways of presenting a character, and we are going to do that in a program. So for instance, I've already made the program name and the main class, and the class and the main method, okay? So the first thing we're going to do is to declare a character. So let's say car1, car2. So let's say car1 is equals to 65, okay? Just a number. car2 is equals to single quotes A, okay? So when you present a character, you just put it in single quotes. What happens if we try to bring the output, okay? car1, and we do the same. So we just copy this, print out car number 2. So Control S, save the program and click run, okay? So what you realize is both of them gives you an output of A. The number 65 represents A in the Unicode. So let's try to add 5, okay? And let's print it again after saving, and you will find it that it's F. Character 70 should be F. So where is 70? Here, and you can see the letter is F, right? That means you can manipulate it mathematically. Let's now look at character literals. Characters in Java are presented using the Unicode character set. So they are 16-bit values that can be converted into integers and manipulated with integer operations, as we have seen by adding 5 to 65 we get F, because 65 is A. If we move, it's like we move 5 steps ahead of character F, A, which is F. In Java, you can enter a character directly, as you can see here, but there are some characters that don't have a representation. For example, tab or enter or create a new line. So it's very difficult. There's no specific character that you will enter to put a new line, but you can use different escape sequence. For example, let's say character 3, we still need to declare that is equals to single quotes \n, okay? We will see that if that would work, and then we have to declare it here. Sorry, that's why I have an error, because I did not declare it. So character 3, okay? So what you see here is the first one is F, as we said earlier, as you can see. The second one is A, as you can see there, and this one is an empty space. As you can see, there is just an empty space here, so it means we just created a new line, blank line. Okay, so if you use escape sequence for such characters that you don't have, and we'll be seeing that as we go along. And it's also possible to present characters in hexadecimal notation, in octal notations, and even in, you know, binary notation if you want to. Okay, so I did pause my video and then I used a calculator to convert from 65. So 1.65, you have it in binary, it's this one, and then you have it in hexadecimal, 41, and 101 for octal. Okay, so what I'm going to do for this is to try and express that, because we are doing character literals, so I'm going to work out that on the program. Okay, so for octal numbers, we're going to put a backslash followed by a 3-digit number. So for example, if I say backslash and followed by a 3-digit number, which is 101, save. So if I print that, you find it's A, because this is an octal number. We converted 65 to 101. Okay, so this is how to present octal characters. Okay, characters in octal form. So if you have a Unicode system that presents the number in octal, you can do that. And then for hexadecimal, backslash u and then the hexadecimal digits. So for example, if I say backslash u, but I'll show you something, it should be hexadecimal 4 digits, so you can see that one is 2. So it's not really enough, because we have only 65 in hexadecimal is 41. So if I say 41, we're getting an error because it's expecting to have 4 digits. So what we do, we can put zeros there. If it's less than 4 for hexadecimal, you put 2 zeros, or you put zeros to fill it up to 4. And for octal, you just also do the same, put zeros, but it should be 3 for octal and 4 for hexadecimal. Okay, so I've made it 4. If I save the program, Control S, and run it, you see we still get A. Okay, because this is hexadecimal representation of 65. For binary, I could decide to present actually this number in binary the same way we did. So I could just do it like this, but remember how to declare a binary number. We have to precede it with 0b. So if I save it, let's look at the first character here, if it changes. So run it, and you see everything is A, because this is the binary. So it still applies when you present it in number form. You can still use the previous knowledge you get from integers, but when you're using single quotes, then you can use this backslash u or backslash followed by the number, as in octal. This is it for characters and character literals, and in the next video we will be looking at boolean. Okay, so thank you for watching this video. See you in the next video.